All right, let's talk about how to balance reactions. So let's learn how to balance them by first learning to take an atom inventory. You can do this if you know how to count, but it's a little trickier than that because sometimes it can be confusing when there's a number out front to know how many of each element there are. If you have two NaCl's, that means there's two NAs and there's two Cl's. If there are two CaCl2s, that means there are two calciums and four chlorines. Okay, let's see if you're getting the hang of this. If there are two AlCl3s, that means there are two Als and six Cls. So you multiply the number out front by the subscript. But wait, there's more. What about something tricky like there are two calcium hydroxides? Whoa. Well, CaOH2 is sort of like this, if you want a visual. And it's saying it's two of this. Okay, so you can kind of picture like there's a 1 here and a 1 here, and there's a 2 for both of those. So, okay, there's two calciums, and then there's two O2s. So we multiply all of those together. So there would be 4 O's, and there would be 4 H's. Because then it would go 2 H2s. Right, but what if it's something like 2 AlNO3, 3? Whoa. Okay. Now we've got two Als because this 3 does not apply to the Al. It's just for the NO3s. Okay, so for N's, we've got 2 times 1 times 3. So that's 6 N's. And then for the O's, it's 2 times 3 times 3. So 18. And if you are a visual person, it might be helpful to draw it out like this. Okay, so here's one AlNO3, and here's a second AlNO3. So now we can just like actually count. So Al's, there's 1, 2. N's, there's 1, 2, 3, 4, 5, 6. And O's, 3, 6, 9, 12, 15, 18. Okay, so you can see what I mean by it's not always super straightforward. Okay, but let's do an atom inventory for this first reaction. Step 1, write down each element underneath the arrow. Then count how many of each are on the left and the right. There's 1 carbon on the left and 1 on the right. There are 4 hydrogens on the left and only 2 on the right. 2 oxygens on the left, and there are 2 plus 1 more, 3 oxygens on the right. It is not balanced. So what do we do? So add coefficients to correct the imbalances. And I want to read the hints first because that will actually help us with the part of number 1. But let's make lines for the coefficients to go out front. Erase those. Okay. So let's read these hints. Sorry, we're kind of going out of order here. Once chemical formulas are written correctly, only change the coefficients, never change the subscripts. Try to balance H's and O's last, if possible. If a polyatomic ion shows up on both sides of the equation, you can treat it as a single item. So you can count like SO4, there's 1 of those, rather than saying 1 S and 4 O's. That's only if it shows up on both sides and doesn't split up. Big hint is to make odd numbers even. It's just helpful when you see an odd number, slap a 2 out front. If the reaction only has carbons, hydrogens, and oxygens, balance in that order. And if you can balance a reaction using a decimal, like 1.5 for a coefficient, you can temporarily write that in and then double everything so that your final answer shows whole numbers for all coefficients. So don't worry, we'll see examples of those. But back to this. We want to balance in that order, C's, H's, and O's. The C's are balanced, yay. The H's are not, so let's balance those first. We need to put a 2 out front of the H2O. That gives us 4 hydrogens, but now there's another oxygen. So there's 2 oxygens there and 2 there. That's 4 oxygens. So now we have to go back to the other side and make this be 4. What times 2 is 4? 2. So then we're balanced. So the numbers out front, you would read 1, 2, 1, 2. Because again, these are ones, but we don't usually write those. Okay, let's do another one. We kind of already did this one in our last activity, but it's good practice. We've got 2 hydrogens on each side, 2 oxygens on the left. Crap, only 1 on the right. So we can only put a number out front to fix that. So that becomes a 2, but now this is a 4. That's messed up. So you need a 2 out front of the H2. And now it's balanced. Let's balance an equation that has some polyatomic ions in it. Okay, first let's write down all of the elements present. We've got H on both sides. PO4 sticks together, so let's keep that. We've got Ca on both sides. And we've got O's on both sides that are separate from these. And then we've got, oh, we already said H's. All right, so let's do our atom inventory. O's on the left, or H's on the left, 3, 4, 5. H's on the right, only 2. PO4 is on the left, there's only 1. PO4 is on the right, there's 2. Calcium's on the left, there's only 1. Calcium's on the right, 3. Oxygen's not involved in PO4 on the left, O2. And oxygen's not in PO4 on the right, 1O. So the tips say wait for H's and O's until the end. So let's start with the PO4s. Let's put a 2 out front. Now we've got 2 PO4s on each side. And how many hydrogens? There's 6, 7, 8. Okay. Our calciums are still not balanced. So let's do our calciums next. We need a 3 in front. That makes our calciums better. But how many H's now? Oh, we got to recount. There's 6 H's here, and there's another 3 times 2. So there are 12 H's. How do we make it so there's 12 H's on the right? What times 2 is 12? 6. So now we've got 12 H's on the right. And now the only thing that's not balanced is, let's check our O's. So we've got 6 O's not in PO4. And then on the right side, we also have 6 O's not in PO4. Yay! Oops, I didn't mean to draw that line there. So everybody is balanced. So the coefficients are 2, 3, 1, 6. And let's look at an example where we can use a decimal temporarily. So if it only has C's, H's, and O's, we want to balance in that order. We've got 2 carbons on the left, 1 on the right, 6 hydrogens on the left, 2 on the right, 2 oxygens on the left, and 3 on the right. All right, so we start with the carbons first. Put a 2 out front on the right. So now we've got 2 carbons, and now we have 5 oxygens. Balance our hydrogens next. Put a 3 out front. Now we've got 6 hydrogens, but how many O's? 4 plus another 3, 7 O's. Yikes, that's an odd number. So what times 2 is 7? 3.5. Now we've got 7, but we can't leave a decimal. Okay, we have to put a 1 in if we're going to start doubling things so that we don't forget to double the 1. The final answer will be 2, 7, 4, and 6. Just double everything. Now you've got double of all of these. You've got 4 hydrogens on each side, 12 hydrogens on each side, and 14 oxygens on each side. When everything matches, everybody's happy. Okay, let's do some more practice. So if you're doing this, you might want to pause the video and then come back to check your answers. All right, first one, we've got 1K on each side, and we've got an imbalance in our iodines. 2 on the left, only 1 on the right. So we want to put a 2 out front. So now we've got 2 I's on both sides, but oh no, our K's are off. So then we need a 2 in front of the K on the left as well. Okay, next one, we've got K's, CL's, and O to balance. We've got 1 K on each side, 1 CL. So far, everything's looking balanced. Oh no, oxygens. Now there's a couple different techniques you could think about. You could use a decimal in front, 1.5, and then you could double everything. Or you could think of that hint, make odd numbers even, and throw a 2 out front. Right, now that makes 2K and 2Cl and 6O. So then you need a 2 in front of the KCl, and you need a 3 in front of the O2. Okay, next we've got just Al and O. 1 aluminum on the left, 2 on the right, 2 oxygen on the left, 3 on the right. Another good example of making odd numbers even. So slap a 2 in front to double that odd number. It also changes the aluminums. So then you need a 4 in front of the aluminum, and you need a 3 in front of the O2 to make it be 6. Whoops, that should be a 6. Okay, let's balance in this order. C's, then H's, then O's. We've got 3 carbons on the left, only 1 on the right. 8 hydrogens on the left, 2 on the right. 2 oxygens on the left, 3 on the right. So now we need to do some balancing. If you put a 3 in front of the CO2, that helps your carbons. And then your oxygens, you're going to need a 4 in front of the H2O to make it be 8 hydrogens. But now your O's are messed up. You've got 6 O's plus another 4 O's. That's 10 O's. What times 2 is 10? You need a 5. Now there's 3 carbons on each side, 8 hydrogens on each side, and 10 oxygens on each side. And there's a 1 out front, which we don't need to write. All right, letter E. We've got another C, H, and O one. 4 carbons on the left, only 1 on the right. 10 hydrogens on the left, only 2 on the right. 2 oxygens on the left, and 3 on the right. We want to balance our carbons first. That makes our carbons even, but now we've got 9 oxygens. Next, we want to do the hydrogens. So put a 5 in front, but that leaves 8 plus 5, that's 13 oxygens, an odd number. What is half of 13? 6.5. This will work temporarily. Everything is technically balanced, but we cannot leave a 6.5. So our final answer will be 2, 13. I'm going to circle these so they stand out. 8 and 10. Then we'll have 8 carbons on each side, 20 hydrogens on each side, 26 oxygens. You don't have to update your inventory since what's most important is your coefficients. But I just did it for good measure. All right, and it looks like we've got some polyatomic ions that are staying together on each side. So that will help for counting. We've got 1 magnesium on the left, 3 on the right, 2 nitrates on the left, only 1 on the right, 3 potassiums on the left, only 1 on the right, and 1 PO4 on the left, 2 on the right. All right, we need to put a 3 out front of the Mg, which makes it be 6 NO3s. So we're going to need a 6 in front of the NO3 here, which also made it be 6 Ks. And so we need a 2 in front of the K3 to make that 6, which changes our PO4s to 2, which is good because there are 2 on the right. So now everything is balanced. The second part of the learning target states that you should be able to determine mole ratio from a balanced equation. The mole ratio is a conversion factor that relates the amounts of moles of any two substances in a chemical reaction. The numbers in this conversion factor come from the coefficients of the balanced chemical reaction. Like here, the mole ratio between nitrogen and nitrogen dioxide is 1 to 2, because those were the numbers out front. If I'm reading this reaction, I can also read this 1 mole of nitrogen gas reacting with 2 moles of oxygen gas produces 2 moles of NO2 gas. So let's do one. For the following reaction, what is the mole ratio of aluminum to oxygen? 4 moles of aluminum react with 3 moles of O2. That's it. All we did was look at the numbers out front. You try. What's the mole ratio of aluminum to aluminum oxide? 4 moles of aluminum produce 2 moles of aluminum oxide, which then we definitely want to simplify. Divide both by 2. 2 moles of aluminum produce 1 mole of aluminum oxide, and that would be our final answer. And that's it for this learning target. Yay!